Okay, for section 5.2.46, the accompanying data represent the homework scores for material on polynomial and rational functions for a random sample of students in a college algebra course. We're going to complete parts A through F using this data. First part wants us to construct a relative frequency distribution with a lower class limit of the first class equal to 30 and a class width of 10. So therefore the class width is 10, so we have 30 to 40, 50, 60, therefore this is 39, 49, and so forth. So in order to do that, we can go ahead and do that on StatCrunch. So I'm going to pull up the homework assignment for this question. I'm going to go ahead, I have the data selected, and I'm going to select Open in StatCrunch. So I'm going to make sure that this matches my information here. So what we want to do is we want to be able to create a relative frequency distribution. So we're going to go up to Stat, and then scroll down to Tables, and then select Frequency. And then we're going to select the column that we're looking at, which is variable 1. And then we want to select using the relative frequency. So we're going to go ahead and do that. And then we're going to select Compute. Now it says we want to turn on binning for this procedure. We're going to select OK. And therefore it creates our relative frequency distribution. Now if you notice here, the class goes from 30 to 40. It should go from 30 to 39. This should go from 30 to 39 as well, but it's showing the class width of 10. So this should be 39, 49, and so forth to match this result. But it's still giving you the same answer. So from 30 to 39, it's 0.025. From 40 to 49, it's 0.025. From 50 to 59 is 0.075. 60 to 69 is 0.125. Same thing up here. 70 to 79 is 0.3, 80 to 89 is 0.25, and 90 to 99 is 0.2. So now we've created our relative frequency distribution. Okay, now what we want to do is we want to be able to draw a relative frequency histogram. So going back to our data, okay, we want to be able to generate a histogram. So let's go ahead and do that. So we're going to select graph, and then down below here we're going to select histogram. Okay, and again we're going to use our column, which is variable 1, and the type that we want to create is a relative frequency. And so we're starting at the lower value, which is 30, and then the width is 10. So now we want to be able to then just create our histogram, our relative frequency histogram. So we're going to go ahead and select Compute. Now let's go ahead and match this. So it's going from 30 to 40, 50 to 60, 40 to 50, 50 to 60, and so forth. And so therefore this is matching this relative frequency distribution. Okay, and then we want to be able to determine the mean and the median score. So in order for us to do that quickly with all this data, we can go ahead and select Stat, and then we want to select Summary Stats. So since this is in a column, we're going to select Column, and then again we're going to select Variable 1. Now over here we can choose to pick any of the items that we want. Okay, we can even choose the sum. You can hit IQR. And so we'll go ahead and do that. So now that these are all highlighted, you can see what's listed over here. Once you highlight them, it shows what you want. And then we're going to select Compute. So now what it's done is it's giving you the column, the amount of numbers that's in the column, the mean, variance, standard deviation, and so forth. And so in this question, we're looking for the mean and the median score. So the mean here is 78.275, and then we can see that the median is 79. So if we take a look at our result here, the mean score compared to what we just did is 78.275, and the mean score is 79, just like we stated. Okay, now in part D it says describe the shape of the distribution based on the results of parts B and C. Well, recall here that in a uniform distribution, the frequency of each value of the variable is evenly spread out across the values of the variable, and the mean is roughly equal to the median. In a bell-shaped distribution, the highest frequency occurs in the middle, and frequencies tail off to the left and the right of the middle, and the mean is roughly equal to the median. In a distribution that is skewed right, the tail to the right of the peak is longer than the tail to the left of the peak, and the mean is larger than the median. In a distribution that is skewed left, the tail to the left of the peak is longer than the tail to the right of the peak, and the mean is less than the median. So if we take a look at our relative frequency histogram, notice that in a relative frequency distribution from part B, reproduced right here, the tail to the left of the peak is longer than the tail to the right of the peak. And so now we're going to compare the mean and the median as found in part C. So the mean score is 78.275, is less than the median score of 79. So therefore, based on this definition of skewed left, the distribution is skewed left. Okay, and then we want to be able to determine the the sample standard deviation in the interquartile range. Now, again, we can either find it by hand, or we've already computed a summary of stats. So looking up here, the standard deviation rounded to 2 decimal places is 13.79. And therefore, we can just get our standard deviation from this data. And then in order to find IQR, you're going to take quartile 3 and subtract quartile 1, which is 88 minus 71.5, which gives us 16.5. But again, if we want to make sure that this gives us our data, we can select that once we choose StatCrunch.